All right, thanks for attending my virtual presentation. My name is Monty Meyerink from Montana State University, and this will be my presentation on my brief research report titled Pre-Service Teachers' Perspectives on Technology Integration in Kindergarten through 8th Grade Mathematics. So the rationale for studying technology integration is largely due to the benefits of integrating technology in K-8 mathematics. So often, this technology that we're talking about is the form of these virtual manipulatives. So these have been shown to increase students' conceptual knowledge of a variety of mathematics topics, increase positive attitudes towards mathematics, increase confidence in mathematics, and increase feelings of competency. Another form of this technology might be mathematical games. These have been shown to increase students' achievement regarding multiplication, adaptive number knowledge, arithmetic fluency, and pre-algebra knowledge. And the rationale for studying pre-service teachers is largely due to the insufficient pre-service teacher preparation that currently exists. So Tondor found that pre-service teachers often felt unprepared to effectively integrate technology on their first day of in-service teaching. And other researchers have pointed out several factors that might contribute to these feelings. That include insufficient access to technology, lack of technology skills, negative attitudes toward technology integration, lack of confidence in their ability to integrate technology, and this belief that their competence might be undermined if students know more about technology than the pre-service teachers do. So the research question for this study is, when prompted to select technological resources to enhance K-8 mathematics instruction after a 2-day lesson about technology integration in K-8 mathematics, for what purpose do pre-service teachers intend to use the selected resource? So the theory that is used to guide this study is Pintadura's SAMR model. So this includes these 4 levels of technology integration. So there's substitution, augmentation, modification, and redefinition. So we can see in this image on the right, at substitution and augmentation, in both of these levels the technology acts as a direct tool substitute. But at the substitution level, there's no functional change in the task, but at the augmentation level, there is some functional improvement. So both of these are in this enhancement domain. And we can see in this transformation domain, there's the modification and redefinition. So at the modification level, the technology allows for a significant task redesign. And then at the redefinition level, the technology allows for the creation of new tasks that were previously inconceivable without using the technology. So this model is used to examine pre-service teachers' intended purpose of mathematics technological resources, and then also interpret their understanding of appropriate technology integration. So the sample of this study is 18 pre-service elementary teachers that were enrolled in K-8 math methods. And these pre-service teachers engaged in a 2-day lesson on technology integration that included an introduction to and exploration of mathematics technological resources, modeling the alignments of K-8 mathematics content with both pedagogy and technology, and then also collaborative activities in which pre-service teachers designed mathematical tasks which utilized technological resources. So following the 2-day lesson, there were a couple open-ended prompts that were used to gather the data for this study. So the pre-service teachers were asked to find one resource and then answer these 2 questions here, which include for what grade level and Common Core State Standard would the resource be appropriate to use, and then explain how that resource might benefit a lesson. And that second prompt was to locate one resource and describe how they might use that resource in a classroom to assess understanding. And then using the SAMR model, we used a priori coding for the analysis. So first I'll go through just an example of an activity that was coded as augmentation. So this was on NCTM's Illuminations website, and this was the Pan Balance applet, and that's shown on the image on the right here. And in this activity, the pre-service teacher plan to use this applet to teach the commutative, associative, and distributive properties. So if we can imagine using, either this virtual version of this pan balance applet or a physical version, there's likely some functional improvement that is present here. But since it's easy to imagine just using a physical version of a balance to show some of these properties, we didn't determine that there was a significant redesign of the task that was due to this technology. So it's probably a little bit more efficient, right? There's some functional improvements, especially since we can see the balance and our equations kind of on the same screen, and they're connected, but there's not a significant task redesign that we said was apparent. So next I'll show an example of a task that was coded as modification. So this task used Osmo's Tanagram game. So Osmo is this red device here. So it has a camera that's pointing down on the table. So students can work with physical tools right in front of this camera, and that will give some live feedback and is connected to this iPad, I believe is what's shown here. So in this activity, the pre-service teacher wanted to use Osmo and this Tanagram game to construct and deconstruct composite figures. One kind of notable quality is that this allows for the concurrence of hands-on practice and technology integration, because students are using these hands-on tools, and then this Osmo allows for some live feedback and connectedness to this virtual representation of this Tanagram. So we decided that there was a significant task redesign here, just due to that connection of hands-on and virtual usage, as well as this instant feedback that's apparent here for each individual student. However, we said that this task was not previously inconceivable, which would have bumped it up to that redefinition level. This could, possibly be done just with some sort of image on like a whiteboard or a wall in front of the students, and maybe someone providing immediate feedback as well. But obviously, using this Osmo here and kind of the setup that this pre-service teacher described is just far more efficient in the classroom. So the results of coding each of the first and second prompt were similar. So for that first prompt, there were 14 pre-service teachers whose task use of technology we decided was something that would augment the mathematical task, and just 4 use technology in a way that modified the task. And then we had the same findings on that second prompt. However, I just wanted to point out that there were a total of 6 pre-service teachers that used technology in a way that modified the task. So it was not the same 4 pre-service teachers for each prompt. So there were 2 pre-service teachers that used technology in a way that modified the task on both prompts, and then there was 4 pre-service teachers that used technology in a way that modified the mathematical task on at least one prompt. So overall, pre-service teachers definitely tended to select and describe the integration of technology in ways that augment a mathematical task. And similar results have been found when examining pre-service teachers in English and social science. So kind of the takeaway question for me with this study was, how might we encourage our pre-service teachers to more frequently integrate technological resources in ways that modify and or redefine the mathematical task? And so ways to integrate technology that really take advantage of the affordances of those technological resources. So I know we have the live Q&A following this presentation, but if you have any questions or comments that we might not get to, please feel free to email me. It's just montymyrick@montana.edu. But either way, thanks for attending, and I look forward to hearing some of your questions and your feedback.